Dear students, let's come to the next topic of your basic electronics, and that is capacitors. Now, first of all, what is a capacitor? A capacitor is a device which is used for storing the electrical charge. It is a passive electronic component and consists of a pair of conductors. These pair of conductors are separated by an insulator, and this insulator is known as dielectric. Now, how to measure the capacitance? There is a measure of a capacitor ability to store the charge. This is known as capacitance. A large capacitance means that more charge can be stored. Now, there is a formula to calculate the capacitance of any capacitor, and that is represented by Q is equal to CV, where C stands for the capacitance, Q stands for the charge, and V is known as the potential difference or voltage. As charge has a unit of coulomb, potential difference has a unit of volt. Similarly, the unit of a capacitance is farads, represented by capital F. As we have seen in the previous lectures, that resistors can be connected in combination of series and parallel. Similarly, capacitors can also be connected in combinations. Now, this combination can be a series combination, it can be a parallel combination. When the capacitors are connected in series, the overall capacitance decreases because in series the total capacitance is given by the formula. They are added in reciprocal. Now, we have seen that the resistances in series are connected with the help of direct combination, whereas when they are in parallel, their reciprocals are added. Similarly, in the case of capacitance, this is a reverse phenomena. In series combination, the capacitances are connected in the form of series and they are added in reciprocal. The situation reverses when we are talking about parallel combination. In parallel combination of capacitors, the overall total capacitance is added as it is added in resistances in series. So, the total capacitance of any number of capacitors is given by Ct is equal to C1 plus C2 and so on up to any number of capacitances. Basically, the capacitors can be divided into two types, polarized and non-polarized. Now, we can see this diagram, which is an example of the non-polarized capacitor. Now, we see that in this type of capacitor we do not find any polarity, no identification which leg is positive, which leg is negative. So, there is no phenomena how you connect it. It can be connected in either ways. That is why it is known as non-polarized capacitor. But in the case of polarized capacitor, the capacitor has a polarity which is identified this black line. This black line indicates that this is a negative line and the other one will have a positive polarity. So, in this case, if you reverse the connections, the capacitor will not work. So, such a polarized capacitor has its own applications rather than non-polarized ones. Now, how to read a ceramic capacitor, what its the value is? Let's suppose there is a value which is given as 102K. Now, the first figure 1, this is the first significant digit, and the second value is the second significant digit, but the third one is the multiplier, as we have seen in the case of capacitor resistors as well, that the third value is a multiplier. Similarly, the fourth one is the tolerance, and this we have seen in the resistances as well. So, actual capacitance of this capacitor comes out to be 1000 picofarad, and it has a tolerance of 10%. This can be 10%, it can be 5%, it varies from capacitor to capacitor. Different features which a capacitor offers: they offer low impedance to alternating currents, they offer high impedance to direct currents, and the reactance of a capacitor is defined by the formula Xc is equal to 1 over 2 pi Fc, and pi has the usual value of the 22/7. Fc is the frequency of oscillation on which the capacitor works. Now, the different applications on which we find capacitors to be used is in the blocking of DC voltages, adjusting frequencies used to generate a time delay application, and smoothing of DC voltages.